Okay. Hello, good morning. I'm jumping into our first example problem in module number 4. So we've gone up to this point, we've done about 4 example problems throughout the years, and we're getting into, again, now still exploring the if then else structure, but more advanced if then else structure. So on the time when we get done with this example problem, I'm going to be asking you once again to upload this to Canvas right here, just like we normally have done. Load up a blank Word document, resave the blank Word document as example 8. You're going to be screenshotting the form during run state, and then screenshot your code that you have built right down below, and then submitting this in the Dropbox. Okay, but understand there's going to be example problem 8A and 8B we're going to go through. You're going to get the program running, and then we're going to enhance it to example 8C. And that's actually going to go to a different web page, but there's links, and I'll guide you through going to that. So once you get done with 8C, you actually will be done with the example problem 8. So like normally, I'm going to jump over to the web resource page. So I'm over there on module 4 right now. I've already logged in, and I'm scrolling down. By now, you guys should have a module 4 program started. You should have been able to have a folder. So we're leaving module 3 and going into module 4. And you can see right here the null, else, and or operator, which I do believe I already have this page open. So I'm going to be talking about the notes here real quick before I jump into the Visual Basic program and highlight things for you. And I'm first talking about the null else with you, and understand that this if structure, you guys should have your feet wet where there's a true and a false path. Okay, we have a true path and a false path, but just to be clear, that sometimes people write programs and not really needing to put anything in the false path. It's either this is true. If it's not true, you're going to forge ahead, whatever test that you're making. But, you know, that's what you call a null else, where it is nothing in the false path. And I've given you guys a flow chart with this. So we kind of may have drawn some flow charts in module number 3. And this example problem, I'm not requiring you guys to draw a flow chart to match it up. It's more about the code and dealing with the logic operators that I'm presenting to you guys with. Okay, but there are going to be some flow charts that I will go back with this assignment, specifically when we get into the nested if. Okay, but just wanted to be clear on the terminology here about if there's nothing in the false path, and understand the true path always comes first. We have an if, and we have a true, and an else, and an end if. Okay, well, the false path comes under the else. Okay, and we'll obviously get exposure to that. But if there's nothing in the false path, that terminology is called a null. Now, as I'm scrolling down here, I'm again going to be talking about this code here. You're not writing this code here whatsoever. I'm just going to be discussing this code with you guys moving forward. So this is getting into the old console application when we had inputs, and then we had an output dealing with the first module. And that's what I'm kind of exploring here with you guys with this. So in this example, you're inputting a name. You're going to have to input a letter A, B, or C. And then you're going to input the person's potentially hours that they're working. And so you can see here, if hours is greater than or equal to 40, okay, and employee's code is A. So there's actually 2 tests that are going on with that. Okay, so if that's the case, and if this is true, if somebody typed in a number like 41 or the letter A, you can see here that's going to output the person's name, the hours, and the employee's code. Okay, nothing fancy about that. Okay, and the false path is showing here an output as well. So we can see the and. The key thing here is utilizing the and, where we had two different variables that are being used here. And so you can do that. You can use the logic operator and in this scenario, okay? So then I scroll down, and then what about the logic operator of or, okay? Or can be also be used. The difference between or and, when you use and, both test needs to be matched to go in the true path. Where if you use or, either one or the other one has to be correct before it goes in the true path. Okay, so there's a difference between and or, but as I proceed on, I'm using that same scenario I used up here. Hours is greater or less than 40, and employee's code is A. I'm using that same scenario here. Hours is greater than 40, and employee code is equal to A. But now I'm adding in the logic operator or employee's code is B. So we have if employee's code is either A or B, then that's part of the input. Then it also would follow the true path. So in this scenario, employee's code can be either A or B. Okay. So as I scroll down, I kind of implement this little program to be adding in more variables. You can see how I added in the person's wage. This is factoring overtime. And overtime, let's talk about that a little bit. And I don't know if you guys know about overtime or not, okay? But in the world of working in the workforce, obviously students as yourself in high school, a lot of times managers don't want you to work overtime because then they have to pay you overtime pay. And so part-time generally is working any hours under 20 or any hours under 40. I know when we get into the holiday season, Thanksgiving and Christmas, sometimes the managers tends to bend the rules a little bit. Okay, but the question is, what factors overtime? Well, generally speaking, that's time and a half. Time, like if I get paid $10 an hour, if I get and so therefore if I'm going to get paid overtime, that would be like not $10 an hour, that would be like $15 an hour. That would be 1.5, right? So if I just dissect this formula here a little bit, you can see I'm using the same scenario. I said hours is greater than less than 40 and employee's code is equal to A, or employee's code is equal to B, then, right? So let's look at this false path real quick. So we have regular pay equals 40 times wage plus base pay. Well, now the base pay, if I scroll up above here, that's like adding the $200 that we're working with here, all right? So you're automatically going to get $200 if you make that if you're in that scenario. So overtime pay is based on the hours minus 40 times 1.5 times the wage. So that is the factoring right there. Every hour you work over 40, what I'm trying to say, every hour you work over 40, you're going to get time and a half. So if you're getting $10 an hour, really you should be getting 15. And this is this middle line here is what's factoring your overtime pay. You have the regular pay between 1 hour to 40, and then you have your overtime pay between hour 41 and how long you're going to work over overtime. Some people sometimes work 50, 60 hours a week. And so there you're looking at 20 hours, 10 extra hours overtime pay. And so this third line right here is then factoring in your pay. And that's basically adding up the regular pay and overtime pay. You can see here pay is the regular pay plus the overtime pay. So you got your regular pay and then you got your overtime and you're basically adding them together. So that's only the true path. That's the true path if this person is working over 40 hours and you're employee A or B. So if you do not meet this criteria, again, you're automatically going to drop down and come into the else path. All right. So understand the else path is just taking the hours times a wage. And so to go into the false path here, therefore, your person must have not entered 40. 39 hours a week, okay? And so you're just basically doing the regular pay. And so basically what comes after the if then else statement is outputting that pay. So this is a snapshot of the console window, trying to work it out. So if I scroll down now, ladies and gentlemen, I'm now going to be getting into example 8. And it's basically using the same model above, all right, using the same model above, but now we're going to use a window application to build this. So what I see here is the form. We got a form here. I got several labels on the left-hand side. I got 1, 2, 3, 4, 5 text boxes, and I'm telling you what to name them. I got a clear button and exit button, and then calculate. So I'm going to flop myself back over to, and I think I've already built this program. I'm going to flop myself back over to this program and just talk about, and you should be, I'm going to hold the program and see if you guys can build this. You can see how I've called it the pay program. Notice how I have called this FRM pay program. I got the pay program. We may have done this program like this back in module number 2, but it wasn't as able to give an overtime pay to a particular person, okay? And we didn't really apply the employee's code, right? And you can see if I go down here, I have the TXT name, TXT employee's code, and I've renamed these TXT work, TXT rate of pay, TXT person's pay, and I got this text box BTN button. So I'm going to go back over the website. I'm going to pause the video and ask you to pause to go ahead and spend a couple minutes building this application right here with the form. Part 1 is building the form and changing the controls on the form. Okay, by now you guys should be have created the form. As you can see here, these controls, and hope you guys are working through creating these different buttons and different properties of this, as we now should go into the code side, and that's going to be working with this calculate. I'm not going to be discussing the clear button. I'm not going to be discussing the exit button in this program, or you will not see the code of the clear or exit, but you can see there's 1, 2, 3, 4, 5 different text boxes. I think you can clearly understand how, at this point, how to clear out the code of this form during runtime, okay? So my code, again, is only going to be discussing the calculate button. All right, so as we get into example B, and now going into the third step, in my notes here, you can see that I have pretty broken this down a little bit, okay? And so we're going to be using dim statements in here, just going back to creating variables. I've created a dim states of regular pay, overtime pay, base pay, and pay, all needed with this program to run effectively, okay? And so these are going to be the variables that I'm declaring as dim statement. We have base pay is equal to $2. So if a student, or excuse me, if an employee is meeting the requirements of base pay, they're going to get $200, okay? Some employees may not get to $200 base pay. Other employees may get to $200. It's part of the program, okay? I'm just throwing that out there in terms of somebody's pay. So again, like I said, we may have done a pay program back in module number 2, but this is a more diverse in working with overtime. And in terms of factoring overtime is important in our society and in people who are working. And so programs needed to have that part of that element. So when we did this example problem way back in module 2, it didn't have anything to do, it couldn't have the capability of overtime. Now we're getting into that, okay? So here we go. We're looking at the code of the if statement. We have the if, else, and if. And understand we have a true path. This is the true path, and this is the false path. But before I get in there, I really want to look at this if line. Look how long that if line is, okay? And so again, like up above in the notes I kind of discussed with you, we're going to be factoring the hours or the person's pay around the hours work. TXT hour works is greater than 40. So if any number above 40, 41, 42, 43, 44, that person then is meeting that's meeting the true, okay? If anything below, during runtime, if you enter in anything below a 40, 39, 30, that's not factored as overtime. Overtime in our society is generally working more than 40 hours, okay? So now we get to operation logic and, right? So this would be a true path. Both requirements need to be tested and need to be true to be able to go in the true path, right? And so I'm just making it up that we have employees A, we have employee category A code, we have a B code, and we have a C code, okay? So if you type in an A or a B during runtime, then that's meeting the qualifications. If you type a C during runtime, that's not meeting it. So that would automatically jump down to the false path. So we have employees code here equals A. Notice how the A is in quotes and it's capitalization. I will be getting in with example problem 8C down below and how we can use the uppercase and lowercase with this example problem. But right now, I just want you to go ahead and type a capital A here. All right. So meeting the qualification for employees code of an A. Then we have the logic operation or same text box. And yeah, we can use different types of controls to test different, either this control or that control, but I want to make it simple by using the same control here as our first logic operator. We have employees code and employees code, okay? So employees code can be either equal to A or employees code is equal to capital B, all right? And obviously, we're following it by the then, all right? So this is all the true path. If this is true, then you're going to drop down and complete the true path. And there's 3 lines of code here. This is where those variables that we have up above are being used. Okay, we have the regular pay is equal to 40 times TXT text plus base pay. So all that basically is doing there is factoring the base pay. All right, overtime pay. All right, so this is the code, and understand overtime, and it's time and a half. All right, and this is where that time and a half, 1.5. 1.5 is basically, when I say time and a half in our society, is doing that conversion. So if I make $10 an hour, 1.5 times 10 is going to be 15. So this whole parenthesis area will factor in the 15 if that's what you're getting paid an hour, 10 bucks an hour. So you're taking your hours worked minus 40. So if I work 42 hours, it's minusing 40. So it's 2 hours timesing your overtime pay here. So this line right here is factoring just the overtime pay. And then following the third line here, pay basically is adding the regular pay and overtime pay to give you your pay. Right? So it's basically 3 lines of code there to be factoring the overtime pay. So if this is true, you're going to go down this route and complete the 3 lines of code. Else, if this is not true, whether you did not work 40 hours or did not have plug-in A or C during the employee's code, you will then dropping down to the else, which is basically factoring the hours times rate. And that's the pay. Now, notice pay is in the true path, and notice pay is in the false path here. True and false path. They're basically coming up with a different number, though, based on your inputs of the true path being, the if path being true or false. Then finally, outside here, we have the text box, which will display your results, okay? I'm trying to bring in your input of the name, pay, and then converting that to a currency here. And this is a line of code that will output the person's pay, okay? So if I jump back over to my program here, which I think I have written, and you can see it here. And if I go over to the line of code, and if I pull this up here for a second, excuse me, you should be able to see the BTN button calculate. You can have the dim state, overtime pay, base pay, all right, the if statement, else, end if, and the end if, all in that structure to be able to make this program work effectively. So once you get here, and if you get in this program to run, you run it. I have some desk checks here that I want you to run through the desk check. And if I scroll down on the web page, you can see a desk check 1, a desk check 2. Okay, you can see I'm telling you put in your name, put in C 1010, and I'm telling you your output should be $100. Okay, the desk check 2, put in your name, try to use the letter A, make sure you use the capital letter A. Hours worked 41, rate of pay 10. I'm telling you your answer should be 615. Maybe do this again and use B. If you use B in these same numbers, it should be giving you the same results. Here's a test, and I want you guys to do, once you get it, test it out 3 or 4 times. Use different numbers. It's always good to desk check it. But what happens if you put a lowercase a? Okay, do something here when you run this program. What happens if you put a lowercase a at 41 and 10? Does it give you 615? Well, if I scroll back up here, is a lowercase a like you see in the quotation there? No. Most likely what will happen if you put a lowercase a, it's going to follow the false path. But I'll get to that next here shortly. But these are two simple desk checks I want you to run your program through. Once you're done, then get ready to go into an example problem 8C. Okay, I'm proceeding on with example problem 8C. You don't actually see it here. There's a link that I'm going to jump to it. If I go back to module number 4, it's actually the next link down. He said UCase, LCase function, example C. I just didn't merge it together. I used to have them separated when I did it, but I just kept it separated. But it's for the most part, it's the same. It's all built the same. I'm just taking you to another page. But I want to review something real quick in my program in the runtime to see how there could be a user error with this. So I'm going to go over to my program right now, and I'm going to run it, and maybe ask you to run it too. All right, I may have just touched base on it, but I'm going to run my program. And in the run state, what if I said my name and I said the capital letter A and I said 41 and you get paid $10 an hour and I hit calculate? And that's probably for the most part, that's correct, right? Because this is following the true path. But what if I come up here and I type a lowercase a? A lowercase a, everything's the same. I went from an uppercase A to a lowercase a, and I hit calculate. Looks what happens. Wow, there's a different number from 615 to 410. And what's happening here, ladies and gentlemen, the program is trying to read this text box right here, and it should be reading uppercase a, but the user made a user error and put a lowercase in, and it's giving the wrong information. So we're going to work with a function now that regardless if you type an uppercase a or lowercase a, it'll automatically give you the proper output, which it should be. So I'm just going to stop the program temporarily. I'm going to go back to the web page, and I'm going to simply click right here. I have the link right here that's going to take me to that next page. I'm going to open a new page. And so hopefully I'm going to have to move things around here a little bit. I'm going to open that page right there. So here I am. All right. So I talk about here, there's something that's called UCase and LCase. And understand the UCase means for uppercase, the L stands for lowercase. And I have defined that right here a little bit. When programming with a string comparison, the .NET environment is case sensitive, okay? And so if the employee code is equal to A, all right, you may have to wrap that around using the UCase function, but you could do the same thing using the L case. If you're going to use an L case, then you need to declare that a lowercase. And so what's happening here, and long story short, whatever character you type in, if you type if you're using, let's go down here, if you're using the UCase, whatever character you type in, it's going to convert that character to uppercase. All right. It's the beauty of that. It's converting that. This UCase function changes that to make sure it's uppercase. Likewise, if you go down here, as I stated here, and you know how I have a lowercase a, if I use the L case here, it's going to convert everything to a lowercase regardless. So I'm just going to stick on the UCase side since we went ahead and had a capital A and capital B, but the same philosophy would do if you wanted to apply the lowercase a or B. So if I go back to my program right now, which my Visual Basic program, and I'm in the live state right with you guys, and notice how my text wrap is wrapping down because I don't have enough room here. So I'm just going to pin up the sidebar so it's all on one line here. And so if I click right in front of the TXT employees code and type in UCase twice, I'm gonna have to type it twice in front of the employees code and type in UCase for the employees code again twice. I put it in twice. I put the UCase in right here and the UCase right here. Just like you see in the notes, ladies and gentlemen, the UCase is there twice because we're testing the control, we're making a test on that employees code twice. So if I go back to that program now and I simply run this program, and like I started with running it, and I type in my name, and look, this time I am going to put a lowercase a in there. I'm just going to keep it the same number, 41. I worked 1 hour overtime, 10 hours, and now watch. I hit calculate. It's now providing me with the correct pay. So regardless if I type it, what if I type an lowercase b, hit calculate, regardless, it's giving me a true output because I have now wrapped my code with the UCase both twice for this. So this is how I'm asking you to end this example problem, by getting exposure to the UCase with this. So didn't really learn many new controls in this. It was all about the operation of the and the or. This is all about code, learning robust code on an if line. I'm not asking you to do any flowcharts here for this example problem. You're going to give me a screenshot of your form and screenshot of your code, bundle it together, and then submit it. Now, from time to time, I may ask students, hey, let me see your program running, right? So I hope you guys are getting something out of the course at this point in time, which concludes us with working with example problem 8.